Okay, here's our first attempt at recording a lesson. Um, this is just going over the homework for future lessons. I'll definitely uh, have like a normal lesson open and go through and do some of the problems. This is just kind of the making sure I can post them and you guys can access them. So just a short video going through the last lesson. So lesson 9.3, which was similar right triangles. Um, the whole thing kind of, there was one concept really. It was if we have a big right triangle, which were just, these aren't the notes, this is just the first homework problem, but they all kind of were the same. A big right triangle, or any right triangle, and we divide it, we draw its altitude, um, and create two other right triangles. Basically, all three triangles are similar. And similarity is a concept we've used now for a couple different lessons. That basically we can partner up corresponding sides to create proportions. So the first couple problems were just getting that practice of breaking the triangles apart and then writing a similarity statement. When I draw them, I always draw mine the same way. So this is what I was asking you to do: is draw the three triangles. Be sure you're showing the three triangles for the other problems. Draw like three generic triangles. Right triangle is a big, a medium, and a small. I always situate them the same way, where I have a long leg on the bottom, a short leg on kind of going up and down, and I do it for all three. You just kind of make the size get smaller. Label your vertices. On these ones you can do it. Some of them don't have vertices to label, but um, as long as I can, follow, okay, F, H, G, that's the big one. I gotta, in my head, rotate, then H, E, G, just kind of following the same order. But that's kind of the key thing, is being able to pull these three triangles apart and see their sides individually. So that's kind of the premise of the lesson. Each individual one then just, you get information that's going to vary. So again, we won't necessarily go through every single problem, but just to kind of get the idea of it here. Uh, Number three is is an example where I have kind of an abundance of information. On the big triangle, I know the short leg is 12. So again, I just generically, before I put any of these numbers on there, just drew a big right triangle with a short leg, long leg, medium with a short leg, long leg, and then a small triangle with a short leg, long leg. And then went back and looked and said, okay, what do I know? All right, on the big triangle, I knew a 20 was the hypotenuse, the short leg was 12, the 16 was the long leg. So I filled all those in. Went to my medium triangle. So as I'm looking at it, I see this altitude, this short leg here, which the altitude of the big triangle will always be the short leg of that medium triangle. So this X corresponds with that side. The hypotenuse is 16, so I put it with the 16. That's actually all the information we need. I did go through and put the information for the small triangle on, but in the end, you end up picking two of the triangles where you have matching corresponding information. So you can kind of follow my work. I matched the 12 with the X, so 12 corresponds with X, the same way that 20 corresponds with this 16 here, the hypotenuse and the hypotenuse. And that's how I set up my proportion. That's kind of the process there. Um, Draw your three blank generic triangles, big, medium, small. Be deliberate. You can tell, you can see I'm being very, like, this definitely doesn't look like the picture, but I'm trying to be very clear to myself so I don't forget and screw this up, because obviously all it takes is really to flip and have this 8 and this Y flip-flopped, and my proportion's going to be completely wrong. So you got to make sure you're getting your long legs lengths where they go, the short leg lengths where they go. So I'm deliberately trying to draw like a super long leg, a super short looking leg, so I don't confuse myself. For this one in particular, we can do, there's definitely some ones where we're going to add, subtract, so I can tell on my hypotenuse here that it's 13. I have to put the 8 and the 5 together, and that's all I know. I don't know anything about these legs here. There's really not, in a case like this, uh, for the whole worksheet, really, there was a few of us doing Pythagorean theorem. There's just not enough information to do it. So here I got to look at my other two triangles now. Now I look at here, my medium triangle. I put a little S and M. That's what those stand for. My short leg is Y. My long leg is 8. So short leg, long leg. And then here, you're going to have that overlap between these two every time. That now this is the long leg of the small triangle, and the short leg out here. So those are the ones that I really have to use. The big triangle doesn't help me out a ton here in this one. So on the cross multiply, I went y matches with 5 around my proportion, and 8 matching with y. I saw this a lot on the homework as for those that submitted it last week. The y times y is y squared, not 2y. So that's something to clean up. We'll run into that quite a bit on these ones. And then pay attention to some of these ones. Some of them just lend themselves better to, I said some for decimals are fine. Like this one was definitely a decimal answer versus 4, where that's a situation where we want to keep practicing with the simplest radical form. So um, that's kind of the process. I'll scroll through a couple here. Another multiply, cross multiply when we're getting an x squared in this case. Um, Decimal situation here. Something like this. You can do this, the z minus 16, like that would be the length of my long leg here, right? We could take the full length z minus the 16. That's how long this would be. I guess I want to maybe try to avoid using that if I can, and we didn't have to use that at all. But yeah, that's the same process for kind of the next onto the back. You can use, so here's an example 8 where, if it helps you to put the vertices on the triangles, on your model triangles, you can do that too to help you kind of figure out which sides go with what, or add vertices here. If it's like, hey, I want to just call this A, B, C, D, and then that if that helps you lay these out here, you can do that as well. I don't know if there's anything here that we hadn't seen on the previous ones, just kind of some different simplifying ones. Um, Next couple, again, there's an example of I'm taking the 8 minus the 2, getting a 6 for that side there. Um, but I think all, pretty much the same type of problem. These last couple, 11 and 12, um, the only thing here that came up that we hadn't seen, you can kind of see some from the work. It's a little bit more, at least for this one. This now we do have to use the b plus 3. So this is really just making sure that we're still distributing. We've seen that with our proportions. You set everything up as you would. Those are b's, b plus 11 for my hypotenuse. That's how long the hypotenuse is there. That's can b. I'm combining my like terms there. That's again on the big triangle. That's all I really know. It's going to come down to these other two small triangles. So the medium triangle, I've got my short leg 6, long leg 8, kind of nice whole numbers. Here my short leg b plus 3, and then using that 6 again for my long leg. So that ends up having to be your proportion. 6 matches with b plus 3 the same way that 8 matches with 6. So cross multiply, just again, make sure you distribute your A to your B and your 3. Over here, kind of a summary type question where initially, well, actually, before I did anything with the 3 triangles, there are spots like this one where it's kind of a summary type question where there's a lot missing. Obviously, an X, a Y, and a Z. But here's the only example really on the whole worksheet where I can use, and I kind of have to use in this case, some Pythagorean theorem to get my y at least going. So I can see on this small triangle here, I've got a 24, the 32. I know 2 of the legs. Let's just find the hypotenuse using Pythagorean theorem. Came out to a nice clean 40. Um, from there, that's when I went into my triangles. You can kind of see it. I did it with X, Y, and Z initially, just on the triangles, and replaced them as I found them. So you can see after I found my 40, I replaced my Y with 40. Same thing here. Now I was able to kind of get some proportions going on. So 40 matching with this 24, the same way that that Z, which was unknown, was matching with this 32. So cross multiply, solve 53 and a third. So I kind of kept it whole for the rest of my calculations, but then again, filling it in here. You could use Pythagorean theorem. You can see my work here. I did Pythagorean theorem again. You could use proportions to find x. So I kind of went out of order. It started with y, found z, and then x. So a little bit of a summary lesson there, or summary example, but good Pythagorean theorem practice along with the 3 triangles. So hopefully that clarifies some of the concepts from 9.3. If you didn't, you kind of just blew through it or whatever, go back and take a look. For today, this will probably be the only thing that I'll have you do. So put a little time in going back and look at it, make sure you can get those numbers as you're doing them. So I'll look for your feedback. I'll post this in uh, Google Classroom, and we'll see how it goes for you. All right, that's it.